This video demonstrates how to modify the built-in transfer behavior of a material flow object with an exit control. This control overrides the built-in exit strategy, meaning that we ourselves have to make sure that the part moves to the station of our choice. The material flow object activates the control as soon as part is ready to move on after being processed. Let's create our simulation model. Insert a source, several stations, and a drain. We rename the single pros to Station 1 to Station 5. To make the object name visible, open the 3D properties of the class object of the single pros. Switch to tab Captions and mark the checkbox nearby Name and Label. The source creates 1,000 parts. Double-click the source to open its dialog. On tab Attributes, select Number Adjustable and enter an amount of 1,000 parts. When we run the simulation, we see that the default exit strategy distributes the 1,000 parts equally among the successors of the stations. We select the stations by dragging a marquee over them and pressing F6 to open the statistics report. As we want a number of objects to use the same control, we program it in a method, which we insert into our frame. Select the method and press the F2 key. Rename the method to MyExitControl. To tell Plant Simulation which control to use, drag it onto the station. The icon of the control then changes to denote that this method is an exit control. When we open the station, we see that Plant Simulation entered MyExitControl into the text box Exit Control. To change back to the method, we click in the text box Exit and press F2. Now we're ready to start programming. Because the method is used as an exit control, Plant Simulation automatically entered the text @.move into the method. The source produces 1,000 parts and moves these to the station. We are going to count the number of incoming parts and then, after a certain number has been reached, move the following parts onto a different successor. To do so, we'll read the statistics value stat_num_in. First, we delete the line which was automatically created. We then declare a local variable. We place the cursor in the first line and enter var n :integer : equals station1.statnum_in. This creates the variable named n and assigns the number of parts entering the station. We click on Control Structures on the Edit ribbon tab and select If, Else-If, End. This inserts an if statement into the source code. First, we replace the condition with our condition, n less than or equal to 100. Next, we replace the then branch with @.move station 2. The @ sign in our source code denotes the part which is going to be moved. This statement moves the first 100 parts to the station 2. Then, we replace the else-if condition with our condition, namely n less than or equal to 300. We replace the remaining then branch with @.move station 3. This moves the next 200 parts to the station 3. We then press enter, type in else, and press enter again. Now we type in the following: @.move station 4. This moves the remaining 700 parts to the station 4. As before, the @ sign denotes the part which is going to be moved. The asterisk in the title bar of our control shows that the source code contains unsaved changes. To save them, we click Apply Changes on the Edit ribbon tab, or we press F7 and close the control. Now we'll run the simulation again and check the statistics report. It shows that the parts are distributed as we programmed them to do. The first 100 parts moved to station 2, the next 200 parts to station 3, and the remaining 700 parts to station 4. To be able to better follow how the station distributes the parts, we reduce the simulation speed. Open the event controller by double-clicking its icon. Drag the speed slider to the left. When we start the simulation again, we can clearly see how the parts move from station to station.